Okay, kids, we're going to get started on a new topic tonight. This is another way of factoring polynomials, and it's called completing the square. When you read over the notes, it might seem a little complex, but I'm sure after we work a couple of these together, you'll see this isn't too difficult. So why don't you take a minute, hit the pause button, copy down the notes that you see there on the screen, and then we'll talk about them a little bit. Now, for completing the square, I want to stress to you that this technique is used when the polynomial can't be factored and we can't use the square root technique. You recall that when we were talking about the square root technique in the past, we said, well, you don't have a middle term, you have just a squared term, and you have, oops, let me see what's going on here. Okay. You don't have a middle term, and you don't have a polynomial you can factor. That's when you use the square root technique. Well, here you've got an example where you do have a middle term, and the polynomial cannot be factored. You can't factor x squared minus 6x plus 11 because the only two factors of 11 are 1 and 11. And so what you've got to do here is you've got to go to a different approach, and the approach that we're going to use is called completing the square. So let me scroll up a little bit here and see what exactly is the process for this. Let's take a look at it. The first thing you want to do is you want to rewrite the equation a little bit different here. We don't write everything on one side and set it equal to 0. We keep the variables on one side and move the constant over to the other side. Now, in order to use this technique, this is very important, the coefficient of the first term, the squared term, must be 1. You must have a coefficient of 1. So if it isn't 1, then you have to divide both sides of the equation by whatever number is being multiplied to the variable, and we'll show you how to do that later. Now, you have the constant over here. Here's your constant. And you want to look at this number right here, the number being multiplied to the x term. Because what you're going to do is you're going to take half of that number, you're going to divide it by 2, and then you're going to square that number. And then you're going to add it on both sides of the equation. You take half of the coefficient for x, you square that number, you add it on both sides of the equation. And when you do that, what you are creating on the left-hand side is a perfect square trinomial. And of course, we know how to factor a perfect square trinomial. We factor it as a polynomial times itself, and from there we should be able to solve this using the square root technique. So let's just take that example problem that we have up above, x squared minus 6x plus 11 equals 0. Let's just take a look at that and see how we would deal with it. I'm going to move this down a little bit, and let's see what we have here. If this was the problem that we were working with, the first thing we'd do is get the 11 on the other side. And so we're going to do that by subtracting 11 on both sides. And now this gives us x squared minus 6x is equal to negative 11. And now we're ready to what we call complete the square. So we're going to look at the number being multiplied to x, which is 6. If we take 1/2 of 6, we get 3. And then if we square that number, we get 9. And so what we're going to do is we're going to add a 9, and of course whatever you do on one side of an equation you got to do on the other, and so we're going to add it on both sides of the equation. What does this give us? Well, on the right hand side we have negative 2. And on the left hand side we have a perfect square trinomial. We have, whoa, went a little too quick there. We have x minus 3 quantity squared. If you factor x squared minus 6x plus 9, you would get x minus 3 times x minus 3, which is x minus 3 quantity squared. And so now you have an equation that looks very, very similar to what we did in our last couple of classes where we had to take the square root of both sides. I'm going to take the square root of both sides here, the square root of x minus 3 squared and the square root of negative 2. Erase this a little bit over here. If you take this and you take the square root of the left side, you get x minus 3. And if you take the square root of the right side, you have plus or minus I times the square root of 2. Remember, we can't take the square root of a negative number and get a real number value, but we can take the square root of a negative number and get an imaginary answer. And so now we have plus or minus I root 2, and to solve for x, we simply have to just add 3 on both sides. And so we end up with x is equal to 3 plus or minus I root 2. And if you're putting that in a solution set, your solution set would be 3 plus I root 2 and 3 minus I root 2. That's called completing the square. We'll deal with it when we come back next time. But basically it's used when the polynomial can't be factored and you can't use the square root technique. That's it for now. Hope you took good notes. Next time you come back, we'll talk about the notes for a few minutes, and then we'll review the problem that we did, and we'll go ahead and start doing some practice problems. Have a good day, kids.